Actually, we have a full session about building VPP, and I will talk a bit more about build system later. But what I will try to do now is basically install VPP on my workstation. So I can show you basically the Debian packaging, and then to install the packages, and then how to configure stuff in startup configuration. So. While we are waiting, so if you want to install the VPP, there is a server called Nexus, which is actually publishing the Debian packaging for and Red Hat packaging for VPP for every single release build. So every commit will actually result in the Debian packaging for that specific one. So this is the Debian packaging, and this is what we have from the different sub packages for VPP. We have the debug one, which is the debug symbols. We have a development package. We have DPDK device. This one includes basically the DPDK header files. VPP DKMS, which is basically the kernel module with IGB.io. We have VPP libraries, and we have the VPP executable. So if you go inside, you will see actually that for every single release, every single Git commit have his own release on this server. So you can really pick the last one. The versioning we are using is we started with 1.0.0, but now we basically started using 16.04, 16.09, so the year.month model. So 1.0.0 is old one, and basically it's always the same schema. 1.0.0 is basically the version. Then we have revision number, which increases with every single commit to the repository, and then finally we have the Git commit ID here. So you can really know that specific package is built from this specific Git commit in the VPP Git repo. So this is old versioning. I think they changed something with the names. Okay. So this is the CentOS and Ubuntu Trust, Ubuntu Zinao. So we are currently in pre-release state. So we recently created the stable branch for release 16.06. So we can see on Nexus server that we start building packages which are release candidate 1, and then we have some commits on top of it. They are basically all the bug fixes to the stable branch. And I think next week we are going with RC2. So this is basically the place where you can pick up the pre-built packages for VPP and install them. And I'm going back to my server. Oops, we have some issues here. Mm-hmm. Yes, it's systemd. Mm-hmm. Yeah. So unfortunately, the situation is that nobody is using Red Hat for development. So I tried it like 3 months ago, and I don't know, maybe it's something broken or yeah. We really look for somebody who is status oriented to look at it and try to make it better.
This is a VPP tree. It works. I downloaded it and configured it and built it on Monday.
Yeah, I never saw that. Yeah.
The only thing I've done is running the page. Maybe it changed something. Yeah. I think that the toolkits inside you type in VM to make that's when you put the configuration. I don't know. Okay, I need to. Okay, you need to do that. From inside the VM. Okay.
Yeah. So if you want to do Bootstrap again, you can just remove file build root /.build.ok. .bootstrap.ok. So because that file is basically a sign that we already bootstrapped the build system. Okay, this is not good.
But essentially, should I do all the building inside the VM? Or you can do either, but not both. No. So right now, right now you should.
So
This is the one I should remove. Bootstrap.ok. Yeah, you can remove this one. And then the bootstrap is maybe too bad. Yeah.
what are you getting?
No, who to target, whether I make kind of AM, music, I make kind of IM. So some automate. But this is not supposed to set up this automated.
Just do git clean -x -d -f. That will wipe out all the
Minus X minus.
f -d. Yes. Mm?
Start before I did. Do you know? What was that?
Oh, your font is too small.
Oh,
Can you?
Yes.
I'm a bit blind.
Even
Okay.
So if you
You don't use sudo. You just make run.
make one in the same.
Yeah. But then make build. So it's not built. But maybe you were running this make command is just starting what is built in your local directory. So it's basically a helper when you're developing, not just quickly start VPP.
Every time I use a local,
it's a different directory. Yeah. Okay, so this is okay. It looks better now. So when we go to build root, you can see that we have Debian files for VPP. We will need to install a few of them, which are mandatory. So first one is dpdk So this is the first package, which is basically just a IGP.io driver. And now we are using the KMS infrastructure to basically build that module. Okay, that is the first one. Second one, which we really need, is libraries. And here you can see what is actually inside the package. So all the shared libraries we have in VPP are basically in this package. And finally, we need to install executable, which is this one. And this package contains the main binary, which is VPP, VPP CTL, which is just a shell script, and some other stuff. And we have systemd service definition. So we can basically use so this is on Ubuntu 16.04. On the 14.04, you need to use start/stop commands like Pierre showed before. It's not running, but I'm not going to debug it now. So you have it running on your Vagrant machines, right? You have VPP as a process running on it. Sorry? Sorry, I cannot hear you. Yes, I mean, it's actually I was just trying to build to show the content. It's not really about, because Pierre already showed how to start VPP in the Vagrant. So let me just start talking about the configuration. So this file, etc vpp startup.conf, is actually the file which contains the startup configuration of VPP. And it's a quite simple one as a default. So you can see there is a section Unix saying no daemon. That is basically telling to VPP that we don't want to fork because actually systemd should do that. Then we have a log, which is tmp vpp.log. And we have full core dump. What is full core dump? It's basically, in some cases, you don't want to really have the full core dump. A good sample is if you're using vhost user, because vhost user core dump, if you have full one, it will basically dump the whole VM memory into the core file. And that core file can be gigs and gigs big. So by default, we are not doing the full core dump. But if you specify this command, it will basically create the full core dump of the VPP. Up-trace is something which basically enables you to what I was talking yesterday. It enables you to capture and replay the API messages which are received. So if you want to debug the API subsystem, it's always good to have this enabled, because you can capture and reapply the same APIs to VPP. So there is basically 3 ways to connect to VPP. You can use the VPP CTL, you can use Telnet, and you can use the serial console, basically the TTY. So for developing, what we are typically using is really using the TTY, because it's most convenient. You can just start VPP and run it. So that is what Pierre was showing before with this make run command. Yeah. So actually, if you type make, you will get a help about few commands which you can use for starting VPP. There is a wipe, there is a build release. So as Pierre mentioned, there are two options always. We have a normal debug version of VPP and the release version. And this makefile is really built for people who are doing development on VPP, and that's why the short one is debug. And then if you want to build release, then you just specify dash release at the end of the command. So if you do make build, it will basically compile the VPP. And then if you do make run, it will start VPP. So this is one way to access the CLI. Another one is if you have the package installed on your VM for Debian image, then you can use the VPP CTL to also access the command line. So what we can do basically is yes, from the root. So the makefile in the root directory is a kind of wrapper for the system inside the build root. Because if you can completely ignore that makefile, but then you need to specify all the bigger command line to basically define the platform and tag. Yes. Yeah. Yes, always, yes. So the debug image is some like 10 times slower than the release image. Yes. So VPP CTL, actually, I will show you what is the VPP CTL. It's basically, so I will just start Tmax and make Yes. So actually, when you are building packages with package Debian or package RPM, it will always create the release image. So debug image is really for developing and debugging while you are developing. Everything regarding the packaging is done on the release build. Okay. Okay. Mm-hmm. So that's because you probably using you started bootstrap from your outside of the vegan VM, right?
I didn't do make bootstrap, but went into this boot and
No. Just go to the top level directory and do make bootstrap. Make bootstrap, then should. Oh, okay. I have some weird problem, and it never happened to me this before. Yeah, so
You actually always have to be in packages and install them. You can just run binaries from.
yes, so the idea is that when you are developing and you are doing something with VPP, you can use this make file to basically compile and quickly test. And packages are when you are really going to install them on the target system.
So that's more for
Yes. So yeah.
full
Yes. So and then the reason why initially we had a VPP listening on the telnet port, but for the security reasons, because there's no authentication, so for security reasons we disabled the telnet in the packaging, and I will show you later how you can basically re-enable the telnet to access. And then we are using VPP CTL, which is basically just using the API client to connect to VPP. So it's a VPP CTL. It's simple shell script which is using the API test command to basically pass the command over the API interface to VPP. Yeah. Okay, so then just do yes. I think we have my wipe. Just a second. Make help. No, wipe will not release it. So just do the git clean. Just do this. And that will basically remove everything which is not in repository. Does it work now? Okay.
You're doing something else.
No, I'm trying to see what's wrong with my huge pages. Okay.
This is the problem I got from when I tried this at home. PPD contains, I think PPD wants 1 gigabyte huge pages, which is stupid CPU doesn't support. Because it's a mobile CPU, so it shouldn't be using 1 gigabyte huge pages.
Okay, so that's something I will talk later. Idea is that VPP by default will use 2 meg huge pages, unless you specify that you want 1 gig or more of memory allocated per socket. And if you do that, VPP will try to see if there is using the sys file system, it will try to see if there is 1 gig pages available. If they are, they will try to use them. If not, it will fall back to 2 meg. So that should be the behavior. But if you, and it works not now here, but but and I didn't get any complaint that it doesn't work.
But this is directly from
No. So you are basically so how it works. VPP is constructing the DPDK command line, and before calling the DPDK initialization, it will basically generate the command line, and it will create the huge page mount file. So this is what you see here, and if you do. You see the run VPP huge pages. This guy. So this is basically the mount which is created dynamically by VPP. And if VPP finds that you have 1 gig pages, then it will be created as a with this flag. But if there is no 1 gig pages, it will be the normal 2M mount. So I will need to reboot my machine, and something is completely wrong. Yes. Okay. So in the build root directory, you will basically see that you have the different subdirectory for every build target. It will be something called VPP _debug native build dash VPP _debug dash native and build dash VPP dash native. So the one which have a debug is debug directory, and the one which doesn't have it, it's release. Yes, and that is what make command is actually doing for you. Make run, and make run release. Yes. So this is the basic that make file is just a helper to save your typing to yes. Yep. Okay, so we have VPP running now as a process. I'm not using it, so yeah. Show and it works cool. Yeah, so I had to reboot my machine. Sorry for that. Okay, so this is basically the what we are calling a VPP debug CLI, and it's mainly built for really debugging and troubleshooting. It's not something we want people use for provisioning or the VPP. That's why we have a binary API, and this is the way which should be used for provisioning, and debug CLI is really for troubleshooting, debugging if there are any issues on VPP. So few commands which are important. For example, show interface. Show interface is basically right now we don't have any NIC assigned to VPP. So basically we have just packet generators, virtual interface, and loopback interface on VPP. If you do show version, you will get some information about VPP. So you can see what is the exact version. You can see who built it, what is the host name, what is the compiler. You can see version of the DPDK, which is used for compiling. And last line is actually showing the DPDK command line, which is passed to the DPDK subsystem. So in this case, we have a socket memory, half gig on every socket. If you do show threads, you'll see that we are running VPP as a single thread right now. So by default, we are using VPP as a single thread application, and this special one stats thread is basically a lightweight thread which is collecting some statistics. But all work is actually happening in the main, in VPP main. Okay, so this is what I have in this server right now. There are a few different interfaces available, and we are going to basically put some of those interfaces to the assigned to VPP. We implemented inside the VPP some logic to avoid, because you basically need to unbind the interface from the Linux and assign it to the VPP. And to avoid that this happens to the interface, which is your management connection, we implemented the rule that all interfaces which have admin app on Linux will not be assigned to VPP. And you can see that right now we have actually, I have all the interfaces here set as up, and that is the reason why VPP don't have any interface assigned. So I'm going to basically, to set state for this guy. Okay. So I restarted VPP, and now we have two new interfaces. We have 10 gigabit 8400 and 8401. Interface naming in VPP is built based on PCI address. So actually, if you take a look into my list of NICs here, you'll see that PCI address for this NIC is 8400, and this one is 8401. Yes? That's my shell script. Yeah. Yeah. Yeah? Which one? Chelsea CT5. Yeah, but this is Linux. So this is basically showing the interfaces on Linux. They're not showing. It's not showing the the interfaces are assigned to DPTK. Yeah, so we can basically doesn't work well here. I'm using SSH over the Cisco router, so the terminal screen is a bit screwed up. That's why it doesn't work. I have another shell script to bind interfaces. Okay. Anyway, I think we are fine with those two interfaces. So show. There is command show hardware, which will basically give you the information about physical interfaces. So you can see basically that we have 10 gig 8400 and 10 gig 8401. It's Intel X710, XL710, and it is connected to the CPU socket 1. And with command send to interface state, we are basically saying that this interface should be up. If you use show hardware detail command, so show hardware detail will give you all the counters which are available for the specific NIC. So inside your Vagrant VMs, you can do the same with your E1000 NICs. So basically, what is the default? Two NICs, right? So first one is management, second one is.
You have three. You have one
so you have two.
And then traditional.
Yeah. Okay. Okay, now I'm going to start VPP. So what I was using now the VPP CTL command, and I was basically connecting to the VPP release image which was installed from the Debian package. But if you are doing development, then it's easy to use make run. And now you will actually see that all the initialization stuff will be on the screen. And the difference between release image and debug image, that prompt is different. So that's the way how you can see if you're running debug. So if there is debug in the prompt, that means that we are running debug image. Otherwise, it is release. Mm-hmm. 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 Do you have admin up on Linux side? Yeah, so you need to. So if you take a look here to the, actually the VPP will tell you that It's keeping the PCI device, which is host interface, this one, and that interface is up. So every time when VPP skips to assign the specific NIC, it will basically give you that information in the startup log. Not managed by. And then you are missing IGB-UAO. You need to install IGB-UAO. If you don't have IGB-UAO driver, then you will have this information. So we are by default using the DPDK IGB-UAO. You can basically switch to UAO PCI generic driver, which is available in Linux kernel. You can do that by basically adding the line to the startup config. So inside the startup file, we have those sections. So we have a section called Unix, we have a section API trace, and we have the big section which is DPDK. And inside DPDK section, we have different commands. I will talk about them also later. One of them is UAO driver. You can basically say which UAO driver VPP should use to bind the interfaces. And the default is IGB-IO. So if you don't specify anything, it will be IGB-IO. If you want to use VFIO PCI, or if you want to use UAO PCI generic, in that case, you need to say something like this. Another thing which you can do in this file is you can basically do a whitelisting of interfaces. So for example, if we do dev, yeah. Sorry. Oh, I'm missing. So Unix interactive basically means that VPP should listen on the console. If you don't specify interactive, and that is not specified in the default startup conf, then VPP will not give you a CLI on the startup conf. So I need to edit. And now you can see that I basically specified that I want to use only device 8401 with this command dev, dpdk dev, with dpdk dev and PCI address. So basically this is a way how to whitelist PCI devices which you want to use inside the dpdk, inside the VPP, and you specify this inside this dpdk section in the startup config. Only this one, yes. Yes. So default behavior is that it will try to use all interfaces on the machine which are not up, admin up. So even if you have a cable unplugged, but interface is up, VPP will not try to bind them. And if you start specifying the whitelist, then it will use only the exact devices which are whitelisted in the startup config. And if you take a look into the generated dpdk init string, you can see actually that there is a whitelist. Yes. So whitelist is also here. Actually, sorry, we are doing blacklisting, but automatically. You cannot specify. But all the devices which are admin app are blacklisted. So actually, in the logic we have in the DPDK initialization, we have the whitelist and blacklist. And if we have the logic is that if if there is a whitelist, we use whitelist. If there is a no whitelist, then we will add all interfaces except they are blacklisted, and they are blacklisted if they are assigned to the kernel with interface hub. Okay, another very interesting command, which I would like to talk a bit about on VPP, is show run. It basically shows you the runtime statistic for VPP. And if you take a look into this output, you will see that we have graph nodes on the left. Then we have the state of the graph node and the counter number of calls to that specific graph node. And you can actually see that two guys here are showing non-zero values. That is a DPDK input. The reason is very simple. DPDK input is polling. So the graph scheduler is constantly calling DPDK input, and DPDK input is trying to see if there is new packets in the queues on the receive side. So this one is showing the non-zero value, and another one is Unix epoll input, which is basically the graph node which is taking care for console input, which is also polling. It's basically a Linux epoll interface. And then we have this interesting column which is clocks. It basically shows for graph node how many clock ticks are spent per packet in the specific graph node. And as I mentioned yesterday, this is basically measured in the way that we call a graph node with the vector of packets. We before calling the graph node, we store the TSC counter. We execute the graph node. When the graph node is done, we again take the TSC counter, and we divide the difference delta. We divide delta with number of packets, and we have the value which shows exactly what number of ticks we spent in processing the specific graph node. This value can be wrong. Yes. So TSC counter on the recent CPU is called invariant TSC, and actually it works in the way that it always ticks and always ticks on nominal frequency. And the new CPUs have the turbo boost, which is basically changing the frequency of the CPU. But even if your CPU is running at 3.6, 3.8 gigahertz, the TSC clock will still tick on the same nominal frequency. So this value will not be correct, unfortunately, if turbo boost is enabled. And you can actually see this if you do turbostat.
I guess it's correct if you actually call it nanoseconds instead of clocks.
Yes, yes. So one of the options which I'm thinking about is basically convert. So you see, in turbostat you have busy megahertz and TSC megahertz. So my CPU in this system is 1.7 gigahertz Broadwell, and TSC is always 1.7. And busy one, you will see if you start sort of doing some workload on the specific core, you will see that this guy will go up to 2.5. And because the TSC is ticking at this frequency, so the number of clock cycles will not be correct in that case. So if you want to get the good numbers, you need to disable turbo boost on the cores which are using VPP. Another option is to convert this and not count cycles, but count basically nanoseconds.
You will actually get better performance with turbo boost enabled.
Yes.
So
Yeah.
sacrifice
Yes.
performance in order to
Yeah, I mean, this is kind of, you know, when you are doing some developing and you're testing your code and you want to see the actually how many clock cycles per packet you're doing in your graph node. In that case, makes sense to disable Turbo Boost to get the correct values from the show run and then tune it. But in production environment, it's basically, of course, it's better to run Turbo Boost. No, it's not. No, it's quite cheap, and we are not reading TSC for every packet. We are reading TSC only for one before and after calling the graph node. So basically, in fully loaded VPP, you have a vector of 256 packets processing in the graph node, and you are basically just dividing the delta with 256. Yes. Well, based on what I was reading is that read TSC is not even, it's executed even outside of the execution units. It's basically special treatment at the beginning of the pipeline. The problem with read TSC is that because if you are not doing memory barrier, it can be inaccurate if you're trying to measure very small pieces of code. And that's why they introduced the read TSC peak instruction, which is basically doing a memory barrier and then taking the TSC counter. Mm-hmm. Mm-hmm. You're talking about kernel descheduling you. You're talking about kernel descheduling you. Well, then the number will be bigger. But the recommendation for the production system is that you isolate the CPUs where you're running the VPP, which will not help you with the kernel threads, but at least it will help you that that scheduler will not assign user process to the specific thread. Okay, I think, I mean, I showed some basic idea how the CLI looks like. We will come back to the details later, right? Any questions, or everybody fine with? Yeah. You don't? Yeah, so DPTK input is not on the list if you don't have any DPTK interface. And we are basically starting the graph node at the moment when we have the first interface. So if you don't have any DPTK interface on the list, if your show interface is not showing any interface, then you will not see DPTK input.
What do you recommend, running bare metal or VB?
I always run bare metal, but that's my yeah. So actually, I never in my life used Vagrant to start VPP. I'm just doing it on my workstation. Or maybe I can just show you another interesting possibility to test VPP without, if you want to run it on bare metal. It's basically using the Linux namespaces. Okay, so this is also documented on one wiki page, I think, more or less the similar configuration. So one of the ways, if you really want to test your feature and just do pings through PPP and back to the host OS, you can basically use the AF packet interface.